strings, and in the string questions you may assume that wherever you go you will find some questions on strings, may it be Hack with Infi or Code Vita or Amazon test or any other company's DSA programming test. You will find some or the other questions from the strings concept. What is so special about strings? One is very beautiful thing about string is you have limited number of values. So if we talk about strings, we have limited values, unlike numbers. See, if you talk about numbers, integers, floating point number, then you have infinity. But in strings you have either A to Z or capital A to Z, or you have special symbols and so on. So one character is equal to 8 bits or 1 byte. So that means you have 2 to the power 8 minus 1, or that is from 0 to 255 number of values, that is total 256 values. Okay, for example, if we talk about this capital A, then SKY value is 65. If we talk about small a, then the SKY value is 97. So on. For B you have 98, for C you have 99, and so on. Similarly here for capital B you have 66, for capital C you have 67, and so on. So here we have limited values, so we can use this concept while counting, and we will solve few problems by using counting concept today. Okay, so before going into those concepts, let me tell you very few basic functions available in C++, which will be very helpful to you while solving the string questions. For example, if we talk about C++, then we have a function called, let's say we have a string str is equal to graphic era. Okay, now if I want to find a particular substring here, then I can use a function called str dot find, and inside the bracket we can pass that substring. For example, if I want to find PHIC, then if this substring is found in the given string, in the original string, then it will return the starting address. So here 0 1 2 3 4 5 6 and so on. So the starting address of P is 3, so it will return you 3, that is index of P. If this whole is not found, then it will not return the starting index, it will return you false. Okay, similarly, if I want to find a particular substring from starting from one place to another place, then I can take out the substring by using substr, and I can write the begin, let's say 3 comma let's say 8. Okay, so this is our begin and this is our end. So starting from third index till 8th index, it will return you the substring. So in this case, what it will return? PHIC, that is 3 4 5 6 space, that is 7, and E, that is 8. So it will return you this substring. Okay, so these two functions may be useful while solving few questions of strings. Okay, so let's move on to some DSA problems directly, in which we will use the concept of counting. For example, I'll give you the first question. Let's say given two strings str1 and str2. If str1 is an anagram of str2, return true, else return false. This is our question. Okay, so now understand what is anagram first. So for example, let us understand what is anagram. So str1 is equal to, let's say, a, b, b, c, and let's say d, and str2 is equal to, let's say, c, b, a, d, b. Now here if you see, the number of letters and frequency of each letter must be exactly same in both the strings. Okay, so here we have one a, two b's and two b's, one c, and one d and one d. So yes, these are anagram. Okay, whereas if I take another example, let's say str1, str2 is given as a, b, b, c, and here a, b, c, c. Now obviously here the two b's are given, whereas we don't have two b's here. No matter what is the order of the letters, order is not mattered here. What mattered is the length of the both strings should be same, and the frequency of each letter must be same in both the strings. So it is no anagram. Okay, similarly if I take one string like this a, b, c, and another string like a, b, here the length itself is not matching. The length of the first string is 3 and the length of the second string is 2, so I don't have to match the frequency also, because it will not be same for sure. So answer is no, it is not anagram. Okay, so we have to find this. One simple approach is what? You take this first character, you take the first character and count the frequency in the whole string, and then you take this character in the second string and count the frequency. If both the frequency are same, then go to the next character. So what I am saying is, start with string 1, first letter. Okay, so start with string 1, first letter. Okay, just give me a moment, light has gone. एक दिन ऐसा चक्कर चला है और मैंने कहा आगे आप देख मुझे. Okay, so start with string 1's first letter, count its frequency in string 1, and check the frequency in string 2 of same character. If it is equal, then go to second character and repeat. Otherwise, return false. But the problem here is the time complexity. Why? Because what you do is you are taking first character, traversing the whole string, that is big O of n, and then you are taking this character only and counting the frequency here, that is big O n. No problem till here, but then you will go to the next character, then next character, then next character. So in the worst case, means if the frequency of all the characters are coming to be same, then it will become big O of n square, the time complexity. Now I'll give you a concept here, just understand this. What is the concept? If the length of the string is, let's say, 1 billion, okay, that is the length of the string is 1 billion, and we use n square is the time complexity. This same method if we use on the input size of 10 to the power 9, then what will happen? You can assume that In the online compilers means compilers like lead code or hacker earth or hacker rank, you have CPU speed of 1 gigahertz, you have memory of let's say 2 MB to 10 MB. You can assume that this, and they give you time before TLE, that is time limit exceed. So time limit given is 1 second to 10 seconds, sometimes 10 seconds also given. So if 1 second is given, then after running your program for 1 second they will announce TLE. If 10 second is given, then after 10 seconds it will announce TLE if the program is not completed. Okay, so now see this. So for 10 to the power 9, 10 to the power 9 square, and this gigahertz is nothing but 10 to the power 9 clocks per second. This is the meaning of 1 gigahertz. So if I divide by 10 to the power 9, then what I am getting is 10 to the power 9 seconds, which is 1 billion second. That is huge. So obviously, if I use this algorithm, this approach for such a large input, I will always get TLE. So I should not use this just after seeing the constraint. So what is my next solution? So let's see the next solution. Next solution is nothing but the counting method. Counting method. And what is this counting method? This counting method can work for many DSA problems of strings. Okay, if you have limited number of inputs, then obviously you can use counting method always. Okay, so what is this counting method? You can use one array, that is count array of size let's say 256. Why 256? Because one character is of 1 byte, that is 256 is the maximum number of values, and for each value you have assigned let's say 0 as the frequency. And now whenever you will find a particular character, then you will increment its frequency. So what I mean is, let's say string 1 is given as let's say I'm writing here this same input A B B C D. Okay, A B B C D. So for this the count array is this. So let's say this is 97, this is 98, 99, 100 and so on. Initially they are initialized with 0. Now when you come across with A, then just do this. So count of str of I. This str of I is what? The first character A, and this count of A is nothing but count of 97. Count of 97, because this ASCII value is 97. So just do increment, so it will become 1. Then when you come on the second, then it is 98, so increment it 1. Then again B, then increment it to 2. Then C, its ASCII value is 99, so increment it to 1. Then you encounter D, then increment the value to 1. Now after going through the whole string for ones, that is big O of n, you have made this counting array. Now when you come across the string 2, then just decrement for every occurrence. So what is our next string is CBADB. CBADB. So for C, the ASCII value is 99, so I will decrement this. For B, I will decrement this. For A, I will decrement this. For D, decrement this, and for B, decrement this. Now in the end, if your counting array is having all zeros, then obviously both are anagram. So how much time we have taken? For traversing this string, big O of n. For traversing this string, big O of n. And for traversing this array, it's big O of 256, which is constant. Okay, so our time complexity is nothing but big O of n plus big O of n plus big O of k, where k is constant. So it is nothing but big O of n. And space complexity is big O of k, because k is the amount of total allowed values, which is constant, or I can say it as big of 1. So we have not used extra space also. Okay, so now let's try to write the program for this. And before writing the program, let's analyze how it is beneficial now. If we have decremented the time complexity and number of values are still 1 billion, CPU speed is 10 to the power 9 clocks per second. Now what will happen? 10 to the power 9 divided by 10 to the power 9, you will get 1 second as the answer. So you can solve the problem of same size. Instead of 1 billion seconds, you can solve in 1 second only. Let's try to write the program for this. So let's say we are returning true or false, that is true is 1 and false is, let's say, 0. That is 0 no anagram, and 1 yes it is anagram. Okay, so let me write the function anagram, and we have string str1 comma string str2. Okay, now after this I need a loop running for I, for index for running a loop, and I need what else, an array, integer array, which is count of size 256, which can be initialized to 0. Like this we can initialize our array to 0. The whole array can be initialized by 0 like this. Okay, no need to run a loop. Now what I am doing is, for I equal to 0 till I is less than str1 dot length, this is my function to find the length of a string 1, and I plus plus, what I am doing is I am incrementing my frequency. I am counting the frequency of each letter by using this str1 of I plus plus. That's all. After this I have to find the frequency of each letter in the second string. So for that I am decrementing it. So I equal to 0, I is less than str2 dot length I plus plus, and count of str2 I minus minus. And in the end, if after running the increment and decrement, if my count array is all zeros, then I am getting the answer as true, otherwise return false. So for I equal to 0, I is less than 256, because the length of the count array is 256. So I plus plus, and what I am doing is here, if count of I is not equal to 0, then here only return 0. Otherwise, after this loop, I can return 1. Okay, and one more check we can do. What is one more check we can do is, here itself we can check if str1 dot length is not equal to str2 dot length, then return 0 here itself, because if the length of the two string is not equal, then they cannot be anagram of each other. Okay, so here we have used, no matter what is the size of the string, we have used only 256 size of extra array, which is constant. And this is running for n time, this is running for n time, this is running for k time, so the time complexity is n only. Okay, so I believe you can find the anagram of two strings now.